viewers of KUTV. Welcome to Elimu Live, and today is mathematics for Form 3, and we shall be discussing the topic vectors 2. I am your teacher, Mr. Ndenga Elphas, and welcome. For the next few minutes we discuss what vectors 2 entails. In particular, we shall be making focus to two important subtopics in vectors 2, which will be about operation on vectors, and then we shall do the calculation of magnitude of a vector and discuss about the midpoint. Throughout the lesson, students, I expect that you'll be able to take notes on what we shall be discussing, share the examples as we shall be presenting them on our board, and also attempt questions. We also invite your contribution towards this show. You can also reach us through the numbers on the bottom of your screen and be able to share your questions. Shall be able to sample them up and see how to respond to them. So welcome once again, and feel much free with mathematics. Ensure you have everything that is required. You have your exercise book and you have your calculator where you shall need to use it. Be able to use it accordingly. In our lesson, our first discussion will be based on operation on vectors. So we are looking at vectors 2, and particularly we are looking at what we call operation on vectors. Operation on vectors. Students, when we talk about operation on vectors, what do we mean, or what are we trying to present? We're trying to present a concept where we want to see the application of the knowledge we learned in Form 1 under the operation on whole numbers. And mainly, we do the three main operation in vectors. We work out addition, we work out subtraction, and then we work out what we call scalar multiplication of vectors. So do we have knowledge on addition of vectors, students? If we are given a concept or a vector to work out in terms of addition, what do we exactly do? So let's start with the first one, is addition and subtraction. Addition and subtraction. Remember that a vector, in this case, in the three-dimension geometry, vectors are represented in terms of x, y, and z. We represent the vectors in terms of x, y, and z, where the x component is an extraction of what the vector represents on the x-axis and the y-axis and z-axis. But in vectors 1 in Form 2, we look at two-dimensional geometry where we focus on the x and the y-axis. Therefore, if we have to work out addition of vectors, students, what do we need to do? In the case where you've been given two vectors, let's say P and Q, and we are required to do addition or to do subtraction, students, what will be the procedure? It's very simple. First, identify the components on the x-axis, the component on the y-axis, the component on the z-axis, and then work them out separately in terms of addition or subtraction. For instance, if we have this case on the board, we are told that example, and you are told, given that a vector A is 1, 4, negative 6, B is negative 3, 2, 5, and C is the vector A plus B. Then you're told to find C. That A is 1, 4, negative 6, B is negative 3, 2, 5, and C is the sum of A and B. So how will we work it out, students? Yes, any trial? Fine. What we do is we highlight the vector A plus B is, what is A? 1, 4, and negative 6. Add B. What is B? Negative 3, 2, and 5. These two vectors have elements representing the X, the Y, and the Z. To work them out simply, add the X, add the Y, and add the Z separately, and then obtain your sum. So this is to mean I'll have 1 plus negative 3, 4 plus 2, and negative 6 plus 5. Negative 6 plus 5. So what happens, students? When we have 1 plus minus 3, what is the result? 1 plus minus 3. Good. The answer is negative 2. What is 4 plus 2, students? 4 plus 2. Good. The answer is 6. And then negative 6 plus 5. What is negative 6 plus 5, students? Right. Negative 1. Therefore, the sum of A and B is the vector negative 2, 6, and negative 1. And in that case, we will have obtained our vector C, because it was to find C, and C was the sum of A and B, meaning that the vector C is negative 2, 6, and negative 1. Number 2, if we are told now to work out a case like this one, question 2, if the vector P is 4, negative 3, 7, Q is 0, 1, 8. Find A. Let's have P minus Q. P minus Q. That P is 4, negative 3, 7. Q is 0, 1, 8. Students, what is P minus Q? Right. What do we do? Good. We do the arrangement of the vectors. And then highlight P is 4, negative 3, 7. And then subtract. What is Q, students? Right. Q is 0, 1, and 8. Q is 0, 1, and 8. So, students, what is 4 less 0? It's 4, right? Negative 3 minus 1. What is it, students? Negative 3 minus 1. Good. Negative 4. And what is 7 minus 8, students? Right. Negative 1. Therefore, the vector P minus Q, students, will be 4, negative 4, negative 1. Please note, students, that these are vectors and their components or elements of this vector. They are not separated by a division line. So you will not say this is 4 over. It's not that way. It is separate, negative 4, negative 4, and negative 1. Very separate and very distinct in this particular case to represent the components on the X, Y, and the Z axis. Part B of the question. You are now asked to find 2Q plus 3P minus 3P minus Q. The examiner says we find the vector 2Q plus 3P minus Q. So what do we do, students? 2Q plus 3P minus Q. Good. We first substitute in the vectors as provided. Our vector is Q, our vector is P. So where it is 2Q means 2 times Q. So you will write 2, what is Q? Q was given as 0, 1, and 8 plus 3. What is P, students? Good. It is 4, -3, and 7. Then you subtract. What is Q? Good. Our Q is 0, 1, and 8. This is what we call scalar multiplication of vectors, students. That there is a scalar. In terms of explanation, a scalar is any quantity that multiplies a vector in this case. That our vector is Q being multiplied by 2, so 2 qualifies to be a scalar. Our vector is P being multiplied by 3, so it qualifies to be a scalar. So when you're doing scalar multiplication of vector, students, what you do is distribute the scalar in the vector. What do we mean? For this case, 2 will be 2 times 0, 2 times 1, and 2 times 8. So what will be the return? This will be 0, 2 times 1 is 2, 2 times 8 is 16, plus, do the same distribution, 3 times 4, 3 times -3, 3 times 7. So what would this be, students? 3 times 4 is 12. 3 times -3, students, gives us -9. And 3 times 7, that is 21. Minus, what is 0, 1, and 8? 0, 1, and 8. So let's do the working out of this. Now we have 0 plus 12 minus 0. The result is 12. Again, 2 plus minus 9. That's -7. Then minus 1 gives us -8. 16 plus 21, that is 37. Minus 8, that is 29. And therefore, our vector 2Q plus 3P minus Q is 12, -8, and 29. Therefore, students, on the element of operation of vectors under multiplication by scalar, addition and subtraction, that is what we work out with. That we have to identify the vector and add the components on the x-axis, same to the y and same to the z. And once you've done the summation or subtraction of the two, you'll be able to obtain the result for what you have been asked. And number 2, you're saying, in case there is an involvement of scalar multiplication, distribute the scalar into the vector to obtain the actual figure. And we multiply every component, every element of the vector by the scalar. Like for this case, it is 2 times 0, 2 times 1, 2 times 8. Same, 3 times 4, 3 times -3, 3 times 7. All this gives you a solution that we can now comfortably say that is our sum of 2Q and 3Q less P, less Q. Question 3. Question 3, students. We are told that if A is 3I plus 2J minus 5K and B is -I plus J plus 2K. Find the value of C in terms of I, J, and K if such that C equal to 2B minus A, such that C is 2B minus A. My students, the question is, if A is 3I plus 2J minus 5K and B is -I plus J plus 2K, find the value of C in terms of I, J, and K. When you're working out such a question, students, remember that there is a representation of vectors in terms of I, j, and k. These are usually referred to as unit vectors. The I simply represents the x-axis coefficients. The j is for the y and the k is for the z. When working out such kind of a case, you are allowed to deal with the coefficient of the unit vectors. But then a question will guide you. Like in this case, we are told to find in terms of I, j, and k. So we shall have at the end of our operation to introduce I, j, and k. So what do we mean by this explanation, students? It's simple. Solution. Identify A as a vector. A as a vector will be 3, 2, and -5. B as a vector is -1. Now in this case it is -I, meaning -1i, plus j, that is 1, and then k is 2. So let's find our C. Our C is twice B less A. Twice B less A. What does it mean, students? It is twice, what is A? 3, 2, and -5 minus, what is A? Sorry, this is B. Twice B will be, B is -1, 1 and 2. Then we less A. A is 3, 2, and -5. Then do the distribution of the scalar into the vector components. So we'll have 2 times -1, students. 2 times -1, that is -2. 2 times 1 is 2, and 2 times 2 is 4. Minus, this is 3, 2, and -5. Then we shall say -2 minus 3. -2 minus 3, students, the answer is -5. And what is 2 minus 2? Right, the answer is 0. And 4 minus -5. 4 minus -5. That makes it 9. So our solution for C is -509. But what's the question? The question is we find C in terms of I, j, and k. So what will that be? -5i. Now j is 0, so we cannot write 0j. We omit it, and so have plus 9k. Plus 9k. And that is our solution for question number 3. The application of the unit vectors in working out operation of vectors. And in this case, not just any kind of a vector, but a 3-dimensional vector where we deal with the representation of the components along the x-axis, the y-axis, and the z-axis. Any question from students? Fine. So we are all at the same page. Therefore, we can move to the next component of our discussion. And I want us now to focus on something we call the magnitude of a vector. Magnitude. Identify the magnitude of a vector. And since this concept was covered again in your Form 2 mathematics, students, under vectors 1, you must have looked at the vector or the magnitude of a vector under vectors 1. It is quite also important to remember that in that particular vectors 1, you were introduced to 2 terms that represent or can be used instead of a magnitude. And you are told by that A magnitude also means the length of a vector, or we use the word modulus of a vector, or we can represent it with the word distance. So whichever word that we use, it will still imply the magnitude of a vector. It being length, it being the distance, and being the modulus of a vector is given in terms of units. And when we are working out the magnitude of a vector, we allow students to write the units of that particular solution. And which units do we use? We just use units. Why? Because it is not specific whether it is meters, kilometers, centimeters, hectometers, or whichever the case. And therefore, when you work out the value for the magnitude of a vector, remember at the end of it all to write the word units, meaning it is what is supposed to be like our SI representation of the quantity you will have obtained. So if we have a vector, given that the vector P, let's say PQ, is X, Y, and Z. If we are given the vector PQ, which is X, Y, and Z, then the magnitude of PQ, is represented as, now how do we represent the magnitude? Because we may find a question where the magnitude is not mentioned, but rather we use a representation. So we represent it with two vertical lines enclosing the vector. Two vertical lines enclosing the vector. That gives us the magnitude of the vector. So this equal to the square root of x squared plus y squared plus z squared. And we're saying the answer to this will be in terms of units. It will be in terms of units. There's something we've introduced here which is not new to you students, because we covered it under vectors 1. And we said that there is what we call the column vectors. So what's a column vector, students? What is a column vector? Like in this case, we are talking about PQ, and we are saying this is a column vector. It's simply a joint representation of a vector as a single vector. So if we have a vector, let's say we have 2 points, P and Q. If we have P and Q are distinct vectors, meaning they're different vectors. They could be representing something different. Then PQ is what? Is the column vector. PQ is the column vector for P under Q. So how does it come to be? PQ is always the final point, which is Q, minus the initial point, which is P. This becomes the column vector. So at some point, we will have to have the column vector before we apply the magnitude of a vector. That is what we represent, or what we call magnitude as students. So let's take a look at an example and see how we will work out this particular operation, students. Our example, we're told that the position vectors of A and B are 4, -2, 3 and -7, 0, 1 respectively. The position vectors of A and B are 4, -2, 3 and negative 701 respectively. Then you're told you find the magnitude of BA to 2 decimal places. We find the magnitude of BA to 2 decimal places. So where do we start, my students? Where do we start such a question? How do we evaluate this? Good. The first thing is to know what is the position vector, right? So what's the position vector? What do we mean by position vector, students? What do we mean by position vectors? Right. A position vector is a vector that originates from the point of origin 0. So in this case, it means, like you are saying, the position vector of A means OA. They start from O. So our OA represents the vector A. And what is it? 4, negative 2, 3. What is B? The position vector of B means OB. They start from O as well. This means representing the vector B, and that is going to be negative 7, 0, and 1. Fine. Step number 2. Right. We have to identify what is BA. Fine. So what is BA, students? What is BA? As a column vector. Good. BA means A minus B. BA means A minus B. Fine. So let's now represent them with the vectors that we have. This is 4, negative 2, 3. We minus, what is B? Negative 7, 0, 1. Good. Take your calculators and do the working. 4 minus 7. 4 minus 7. What is the answer? 11. Good. Negative 2 minus 0. Negative 2 minus 0. Right, that's negative 2. And then 3 minus 1. 2. 3 minus 1 is 2. Therefore, we have obtained our vector BA. A column vector representing BA is 11, negative 2, and 2. But then remember that we've said this 11 is for the X, negative 2 is for the Y, and 2 is for the Z. So how do we then apply the concept of magnitude? So BA then becomes the square root of X squared plus Y squared plus Z squared. X squared plus Y squared plus Z squared. X squared, that is 11 squared. Y squared, that will be negative 2 squared. Z squared, that will be 2 squared. Then we find the square root. We find the square root. That we have 11 squared plus negative 2 squared plus 2 squared. Working it out, 11 squared, that gives us 121 plus negative 2 squared, students, 4. Good. It's not negative 4 but positive 4. And then when you square 2, again we get 4. So we shall have the square root of 129. Now let's everyone take his or her calculator, students, as we get the square root of 129. Remember, the instructions are we get the value to 2 decimal places. So let's take our calculators. Have the square root of 129 on your calculator. Are we all there, students? Good. What is the square root of 129 from your calculators? 11.36 units. 11.36 units. That is the solution for question number 1 on the magnitude of a vector. The square root of x squared plus y squared plus z squared. Any question from students? Are we all together, students? Good. So let's look at the second example. Number 2. Number 2, you are told to determine the magnitude of the vector, TR, given that T is 3I plus 7J minus 6K and R is minus 2I minus 3J plus K. Determine the magnitude of the vector TR, given that T is 3I plus 7J minus K and R is negative 2I minus 3J plus K. That is the question. And I want us to discuss the procedure for working out this question as a class so that we get a solution as a class. Where do we start, students? That is the question you have. Yes, any trial? Good. What we do first is to write the vector T and R, excluding the unit vectors. We write I, our T is 3, next, good, 7, then negative 6, right. What is R? Again, from these coefficients, R will be, take negative 2, right, next, negative 3 below it, good. What about this? This is K. What do we write? Fine, that is 1. It's like saying 1K, therefore we write just 1. Step number 2. Somebody else to try? Good. TR. We now express TR as a column vector. What is it going to be? R minus T. R minus T. So let's have it here. Negative 2, negative 3, 1. You minus, what is T, students? It is 3, 7, and negative 6. Now, what do we work out together? Negative 2 minus 3, negative 5. Next, negative 3 minus 7, negative 10. What about 1 minus 6? Good, that will be 7. Therefore, we'll say our TR, which is the magnitude, will be the square root of x squared plus y squared plus z squared. So let's have negative 5 squared, next, plus negative 10 squared plus 7 squared. Then we find the square root. We find the square root. So let's have negative 5 squared. That gives us 25 plus negative 10 squared is 100. Remember, when you are squaring a negative number, it has to be in brackets. If you just put in your calculator negative 10 squared, it will give you negative 100, and that is wrong for this case. So make sure you use your brackets well to have the right answer. Then plus 7 squared, that is 49. So we have 100 plus 49, that is 149. Then we add 25. That will be 174. 174. So again, students, let's take our calculators. Let's turn to our calculators. And as we turn to our calculators, we need to find the square root of 174. 174. So we'll have the square root of 174. Square root of 174, students. Remember, we will give our answer to a 4, to 2, or to 1 decimal place, depending on our estimation, because this question has not given us the number of decimal places to use. Therefore, we shall give it to 1 or to 2 decimal places, and that will be 13.19. 13.19 units. 13.19 units as our magnitude. Good. Where you find such kind of a question, students, ought to show the steps, because mathematics is about how you present your work. Make sure your work is orderly, and then you are straight to the point. You make it easier for whoever is marking to mark it with ease, and also be able to award you marks for every step, every stage shown. Because what is important is, are you able to show the working? And showing the working means that you know each and every stage that is required to be worked out whenever you're dealing with a question in mathematics. And that is a concept we call the magnitude of a vector. Finally, students, as we analyze these concepts, we will need again to merge with what we call the midpoints of midpoints. We'll have to finish up with midpoints. Midpoints. Whenever we mention midpoints, we mention half of the point. And something to remind you, just from vectors 1, students, a midpoint originates from a particular set of points. You cannot find the midpoint of 1 point. No. Because mid means halfway. For us to get half of a point, we need to have at least 2 points. Number 2, remember, it is a point, and a point is defined by a full set of coordinates. We have coordinates in 2 dimensions. We write them in ordered pair, x and y. Ordered pair, x, y. This is a coordinate in 2 dimensions. But in 3 dimensions, the coordinates are written in ordered pair of x, y, z. X, y, z. Therefore, we must have 3 components represented in the magnitude, in the midpoint of a particular set of points. Remember, a midpoint is not a vector, or may not necessarily be a vector, but it could be a representation of a certain set of points that you have. Let's look at this case. If we have a point, if we've been given a point A with x1, y1, and z1, and another point B, x2, y2, and z2. These are 2 points. They are representing x, y, z for each of the points. If we are told to get the midpoint of AB, the midpoint of AB implies, look at what is on the x, half of it. That is x1 plus x2 over 2. Go for the y. y1 plus y2 over 2. And go for z. z1 plus z2 over 2. And then this has to be enclosed in brackets. We discourage the kind of students who write 1, 2, 3 as a coordinate and then leave it that way. Ensure that your coordinates are well and close in brackets, and that is the midpoint of a particular set of points. It can only be for 2 points. We cannot find the midpoint of 1 point because we need to have a set for us to be able to tell that this is the midpoint of these particular points. Let's put it in practice and look at an example that we can discuss together. Number 1, given that M is the point 1, 6, 10, and N is 3, 5, 7. The coordinates, find the coordinates of the midpoint of MN. Find the coordinates of the midpoint of MN. We find the coordinates of the midpoint of M and N. Whenever students see such kind of a question, they rush, forgetting the important aspects being presented in the question. You will find a student going for MN because we've done the column vectors, and in this case, if we are to find MN anywhere, then what will it be, students? N minus M. So you'll find a student rushing to this kind of a situation as a solution to that question, forgetting it is about the coordinates of the midpoint. So you need to be very careful as you analyze any particular question in mathematics. Know what the examiner asking you to do and how do you approach that particular question. So let's start. It's the midpoint. And then we have M and N. M has X, has Y, has Z. N has X, has Y, has Z. What I mean is, this is M, this is X, this is Y, this is Z. N, this is X, this is Y, and this is Z. Therefore, when you're working out the midpoint, you have to combine the two. Our midpoint will be X1 is 1. X2 is 3. Divide by 2. Y1 is 6. Y2 is 5. Divide by 2. 10 plus 7. 10 plus 7 divided by 2. So 1 plus 3 is 4. Divided by 2, 2. 6 plus 5, that's 11. Divided by 2, 5.5. 10 plus 7 is 17. Divided by 2, 8.5. Therefore, our midpoint is 2, 5.5, 8.5. Did you all get that, students? Good. So that is our midpoint for question 1. Finally, let's look at this example. Number 2, we're told that the position vectors of P and Q are 4, 7, 8 and -2, 6, 1 respectively. A point T is the midpoint of PQ, and point N is the midpoint of OP. The position vectors of P and Q are 4, 7, 8 and negative 2, 6, 1 respectively. A point T is the midpoint of PQ and N is the midpoint of OP. Then you're told to find Q minus P, so negative 2, 6, 1 minus 4, 7, 8 minus 4, 7, 8. So this will be negative 6 and this will be negative 1 and negative 7. And finally, for our question today, part B, we find the coordinates of T and N. Coordinates of T and N, students. Remember, T is the midpoint, so we shall say T is the midpoint of P and Q, that is 4 plus negative 2 over 2, 7 plus 6 over 2, and 8 plus 1 over 2. 4 plus negative 2 is 2 over 2, that is 1. Then this is 13, 6.5, then 4.5. N being the midpoint of OP will be 0 plus 4 over 2, 7 plus 0 over 2, and 8 plus 0 over 2. So you work out this one, this becomes 2, 3.5, and 4. You will have worked out the midpoints of the N and T. Students, that is our discussion today, that we focus on vectors 2, and we've analyzed 3 main areas: the operation on vectors, where we did addition, subtraction, and scalar multiplication. And number 2, we've discussed what we call the magnitude of a vector, and thirdly, we've discussed the midpoints of a set of points. So whenever you're given a question on those 3 areas, try as much as possible to present your work in a manner in which we've been able to discuss. And as always, we encourage you students to do more practice. Especially when you are alone, you are free, make sure you do as many questions as possible to perfect on your knowledge in vectors. And as you revise vectors as well, remember that you can be able to blend vectors 1 and you blend it to vectors